Alright, today we want to look at Einstein's equation of photoelectric effect. First of all, let us look at the definition of photoelectric effect. Photoelectric effect is the emission of electrons from the surface of a metal when electromagnetic radiations of appropriate frequency or wavelength falls on the metal surface. The electrons that are emitted as a result of photoelectric effect is called photoelectrons. Now, from this definition, let us deduce some formulas here. Let us take this as the electromagnetic radiation, all right? And take this as the metal surface or the metallic substance in which the electromagnetic radiations are incidenting on it. Now, this electromagnetic radiation possess energy, which is called energy of the photons, or photon energy, all right, photon energy. And this energy is given as, that is HF, where H is called Planck constant and F is what? Frequency. Now, these electrons here are also bonded with some particles. Now, before the electrons can be emitted, when the photons strike, they need some amount of energy that can liberate them from other particles. And this minimum amount of energy needed by these electrons is called work function, which is represented by W naught, or we can use this symbol for it. Now, one thing we need to know is that if the energy of the photon is greater, all right, than the work function, what will happen to the electrons? These electrons will be ejected, or they will be emitted with some kinetic energy, all right, with some kinetic energy, which is Ke. So from this analysis, we can say that the energy of the photon is equal to work function plus kinetic energy, as we can see here. Now, let us look at this. The electrons that are emitted, they possess mass and they also move with some velocity. Therefore, we can say that our kinetic energy should be equal to half multiplying the mass of the electrons times velocity squared. Therefore, we can say that HF equal to work function plus half multiplying MeV squared. And this is what we call Einstein's equation of photoelectric effect. From this equation, we can deduce other formulas from it, all right? Now, let's see what we can do. Now, we also know that the frequency of a wave or frequency of electromagnetic radiation is equal to speed of light divided by what? Wavelength. So, from this expression, we can have H multiplying C over lambda equal to work function plus kinetic energy, which is half MeV squared. So this formula can also be used to do calculations as well. Now let us look at some instance here. Now, if the photons strike the metal surface, all right, and the electrons absorb all the energy of the photon, then it means that the electrons will not be emitted. And if the electrons are not emitted, then we can say kinetic energy is equal to 0. Now, if kinetic energy is equal to 0, from this equation, we can have HF equal to W naught, as we can see. So we can also have this relation here, as we can see here. So we can say H, deduce another formula here, will arrive at this. Now, from here, all right, we can have H F naught equal to W naught. So this is a relationship that exists between what we call threshold frequency. So F naught is equivalent to what we call threshold frequency. That is the minimum frequency below which no photoelectrons can be emitted. So we can have this relationship here, F naught to what? To work function. Now let's see what we can say. If HF naught is equal to work function, what can we say? Then from here, when we have HF, anywhere we see work function, we are going to put HF naught there. So we have HF naught, all right? HF naught should be equal to HF should be equal to HF naught multiplying kinetic energy. So here too we can have a formula that exists between F and what? F naught here with kinetic energy, as we can see here. So from here we can also deduce another formula here, all right? So it's all about formula deduction. Should be equal to, that is half, all right, MEV squared. So we can have these formulas based on how the question will be given and the type of formula we can use. Now let us look at this kinetic energy here. Now this kinetic energy at maximum, we say that is equal to what we call stopping voltage. Is equal to stopping voltage, all right? Stopping voltage, all right? Which is measured in EV, that is electron volt. So from this analysis, we can say kinetic energy should be equal to EV. Making V the subject, V will be equal to kinetic energy over what? Over E, which we can break it as V equal to half MEV squared all over what? E. And where V is called stopping potential. So we introduce stopping potential in the relation to kinetic energy to do calculation. Now let us look at some relationship here again. If KE is equal to EV, all right? Then from this equation we can have HF equal to work function. Now our KE, which is equal to EV, then we can have this, all right? Therefore our V will be equal to HF minus work function all over what? Electron charge, as we can see. So we can also break this formula down as H, all right, multiplying C over lambda minus W naught all over what? Electron charge. So these formulas can be used at any instance based on how the question will be given to us. So these are some few formulas that we can have here. Don't forget to practice it, so that anytime question is given, you can use it. In our next meeting, we are going to learn how to use these formulas. Thank you.